Hello everyone, welcome back to the channel. I hope you all are doing very well. So we will see today's daily challenge on Leetcode and let's try to solve it together. Walking robot simulation 2. The width cross height grid is on an XY plane with the bottom left cell at 0, 0 and the top right cell at width -1, height -1. The grid is aligned with the four cardinal directions north, east, south, west. The robot is initially at the cell 0, 0 facing east. The robot can be instructed to move for a specific number of steps. For each step, it does the following: attempts to move forward one cell in the direction it is facing. If the cell the robot is moving is out of bounds, the robot instead turns 90 degrees counterclockwise and retries the step. After the robot finishes the moving the number of steps required, it stops and awaits for the next instruction. So you need to implement this class, uh, which at first initializes the robot at a particular position, and then it instructs the robots to move forward num steps, this step function. Then this pause function will help you get directly to the x comma y coordinates in which the robot is currently at, and this get direction which should tell you in which direction the robot is currently facing. So as in this example, you can see the robot starts with facing east and goes on moving along the perimeter of the width comma height grid. Okay, so it is quite obvious that initially, since you have a grid like this, it is told that the bottom left portion is 0, 0 and the top right portion will be uh, width -1, height -1. I hope you can easily understand that. And initially, the robot is facing in this direction, in the east direction. And as told, the cardinal directions are east, west, north, south. Okay, and since initially it is in the east direction, it so let's say it tells you that first move 5 steps, then depending on the size of the grid. So let's say if the grid size is 6 cross 6, you will be reaching somewhere here, and where this is 6 and this is 5. Okay, and yeah, if the grid is only, let's say, 3 cross 3 or let's say 4 cross 4, right? Then, if you are asked to move 5 steps, then you will move all the way to here, complete 4 steps, and then again move 1 step to this. Okay, 1 step to this you will move and move a total of 5 steps in this way. Similarly, if you are asked to move 100 steps, then you will complete 25 cycles. Okay, if there's a 4 cross 4 grids, you will complete 25 cycles. Okay, so one thing you must notice that after completing one cycle, it keeps on repeating the same number of cells. Okay, so and in this problem, if you look at the constraint also, okay, so if you try to see the constraints, uh, you have at most 10 to the power 4 calls in total will be made to step, uh, get pause and get direction, and num is 1 if 5. Okay, so you should not be trying, you should be trying to solve uh, in O of 1 in each of these three functions. Okay, so you should try to not use any for loop in each of these three functions, and you might use some for loop or some pre-computation in this particular initialization function only. Okay, because that is called only one times, but these three functions can be called 10 to the power 4 number of times. Okay, so you should try to solve them in O of 1 time. So again, combined with this observation that you are repeating these cells again and again. Okay, so you can try to have all these cells linearly placed. Okay, what do I mean by linearly placed? So let's see, let's say you have a grid which is 4 cross 4 grid. Okay, length and height, width and height are equal, and they are 4 cross 4. So what will be the coordinates? It will be something like this. I hope you can easily understand that. 1 comma 0, 2 comma 0, 3 comma 0, uh 4 comma 0. This is 4 comma 1, 4 comma 2, 4 comma 3. Again, this is what? 4 comma 4. Okay, and so on. We have it. Now we are moving backwards, right? So this will be 3 comma 4, this will be 2 comma 4, this will be 1 comma 4, and this will be 0, comma 4. And again, this 4 will also start decreasing, so it will be 0, comma 3, 0, comma 2, 0, comma 1, and all the way back to 0, comma 0. So these are the coordinates in direction which they will keep on moving, and each of these coordinates has a particular direction. So you can predefine that, hey, this direction is east, this direction is definitely east. As it is moving like this, it will always be east no matter how many cycles you completed. Okay, so this is east, this is east. Then again from this you started going north. Okay, you started going north. Then again from this you started going west. Okay, again from this you started going downwards, so which is south. Okay, so yeah, so I hope you do understand that this pattern is only repeated again and again. So what you can do is very simple. You can try to store all these elements in a vector. Okay, so you can have a, basically I want to say you that you should have a vector like this. Okay, what is what is the purpose for this vector? It stores all the possible directions all the way till 0, comma 1. Okay, this is the last element. Okay, so if you start from this, you will go all the way back till here. This will be your first element and this will be your last element. So all the way back to 0, comma 1. Okay, so what is the purpose of this vector? Initially, I will have an pointer. Okay, I will call it id, which is initially 0. So it says that initially your position is only 0, comma 0. So if you want to, let's say, move k number of steps, okay, no matter how high is k. So let's say k is 100 or 1000 or even 10,000. All you have to do is add this k or this number of steps which you want to go, add the number of steps to id. Okay, now you this might exceed this index. Okay, but for that you can easily take whatever this vector size, let's say whatever this size is, let's call it sz. Okay, so you can take a modulo sz. Okay, this will again give you the same indices. So when you take a modulo in a vector, when you want to iterate the vector in a cyclic manner, so after the last element it automatically goes to the first element. Okay, I hope you already know how this works. And id plus k, in this way you can iterate this vector again and again and again. Okay, just by adding and performing a modulo, you are skipping the for loop which you had to do for going through, let's say, 1,000 steps. Okay, so this is all the trick you need to understand. Okay, and for this, for these cells, you see, for a particular cell you also have directions. Okay, so you see this is the direction east, east, east. Okay, and this again starts to have north. So we can encode the directions also. We can say that this is 0, north means 1, east, north, and let's say west means 2, and south means 3. You can encode the directions also, and you can say that this particular cell will always make the robot face in this direction. Okay, and you can have another vector. So this is one vector, let's say v1. This is another vector v2, where you can store all the directions also, corresponding directions. Okay, so let's say id number 7. If you go to id number 7, 0, 1, 2, 3, 4, 5, 6, and let's say you go to 6, id number 6, you extract this particular cell 4, comma 2, and you extract the direction which is north. Okay, so corresponding id should give you so what we will do essentially, whenever there is a move function, you want to move the robot, all we will do is this. All we will do is add the id with the number of steps and take it modulo size. Okay, this is all you have to do, and automatically the positions and the directions will get updated. Automatically it will get updated. How exactly is that? When we will try to extract using this id, we will go to the correct position as well as the direction. So yeah, that is all for this problem. You should just need to make this vector correctly in your pre-processing as well as this direction vector. So that will be all. So let's see what all things you need. First of all, you need to have a direction, integer ID. In which particular ID are you currently present at? I will have another Boolean variable moved to make it to let the program understand whether the robot has moved or not. So there can be something like you did not make the robot move anything and still you are asking for queries like get positions and get directions. So if the robot is not moved, so one thing you must see that uh, there is one small edge case. Okay, what is that edge case? So when you start with this movement and let's say you come to 0 comma 0 again, at first when you have not moved, the 0 comma 0 position is facing east, but each further subsequent cycles, okay, you do any cycles, whenever you will reach 0 comma 0 you will be facing south. So this is a small thing which you need to take care of. So if the robot has not moved, then 0 comma 0 position is east, otherwise the 0 comma 0 position is south. Okay, so that is the thing you need to take care of. Okay, so that is why I keep a Boolean value moved, which I will initialize to false in this constructor. And again, I need a vector of pair, int comma int. Again, why I am using this vector of pair? In order to construct this particular v1 vector, which gives me the all the positions placed linearly, which I can easily access using this ID. Okay, and I also need another vector direction, which will tell me in what direction my particular index is right now at. Okay, uh, yeah. So I can have four for loops here in iterate in initializing this position. Why four for loops? Because I want to iterate through all these four directions. Okay. So I want to iterate here, from here to here, this to this, and to this to this. These four directions, I want to place it linearly in a vector. For first, my for loop will go into I equals to 0, I less than width. This is width, right? This length is width. So it will go till width and I plus plus definitely. And for this loop, if you see in this position, you have already reached. So I will start for j equals to 1, not j equals to 0, because this position is already facing the east. From the 1 position, you are facing a new direction. So for j equals to 0 and j less than height, you will go. Okay, j less than height. After reaching height, you see this position coordinates is nothing but width minus 1 comma height minus 1. So from the next coordinate it will be width minus 2, right? So for the for loop for this will be for I equals to width minus 2. Okay, and I greater than equals to 0, I minus minus. I hope you can understand this. And for this the for loop will be for j equals to, this is nothing but what will be this in terms of height. See, this is if this is h minus 1, this will be h minus 2. So for height minus 2, okay, height greater than 0, j minus minus also again, right? So I hope you did understand how we will use these for loops to create this position as well as this direction vector. So at first, as told, let's have this for loop int I equals to 0, I less than width, I plus plus. Okay. What all things we will do for here? Again, simply we will push back this position with x comma y coordinates only. Okay. So initially when you are at the bottom this direction, okay, when you are moving along this line, your x comma y, if I'm trying to ask, x will have some value and y will have a value of 0, right? So y will be 0 and x will be I. Okay. So what you will push back is I comma 0. I hope that is very simple. And for direction dot push back, you need to push 0 because 0 means east. That is the thing which we encoded, right? After doing this, you need to simply have 4 more for loops, okay? 3 more for loops, total of 4 for loops. So the second for loop, as I told, will be j equals to 1, j less than height, okay? So j will be 1, j less than height, okay, and j plus plus. So once you have reached this, what will be the coordinates of this? If you try to see, the coordinates will be width minus 1 comma j, right? X coordinate will always be width minus 1. So width minus 1 and j. And the direction for this will be 1, direction for the next one will be 2, direction for the next one will be 3. I hope that is not difficult to understand. And for this I, again now we will start with width minus 2. Width minus 2, I greater than, or you can call greater than equals to 0, I minus minus. Okay. And what is the coordinate of this particular? We understood this and this, right? For this particular coordinate, it will be again x will be changing, so x will have a value of I, and y will have a value of height minus 1. Okay, so I comma height minus 1 is the thing which we need to push back in position. So I comma height minus 1. Yeah, that is all. And last iteration we are left with. So for that, we will have the iterating variable 0, which is starting from what? Height minus 2. Okay. J will be greater than 0 and j minus minus. Okay. Uh, what will the value look like? This time you see again, this x coordinate will be 0. So 0 comma j is what we need to push. So yeah, we just simply put 0 comma j, and this direction again, without seeing only you can understand this will be 3. Now the things we have pushed is starting from 0 comma 0, but again the direction of 0 comma 0, as I told you initially, is 0, I have told, but it is mostly 3. So direction of 0 is mostly 3. I hope you do understand why, because only in the first iteration, only when the object has not moved at all, 0 comma 0, then the object is facing east. But in each further subsequent cycles, at 0 comma 0 on, always the robot will face south. Okay, so the robot actually faces south in direction 0. This is the edge case we need to take care of. Now in this step function is everything is very simple. In this constructor, we also need to initialize this id equals to 0 and move equals to false. Okay, so yeah, after you have taken a step, you can simply make this moved equals to true. And what else is that you can update this id. Okay, id equals to id plus num modulo pos dot size. Okay, I hope you do understand. So now all you need to maintain, you have created this big vector, right? Since you have created this vector of pairs as well as this direction, all you need to take care is have a particular ID. Okay, update only the ID. So if you update the ID in this manner, you can easily tell which particular position or which particular direction I am at. So if someone asks you which particular positions you are at, you can directly tell the answer. It will be position of ID first, which is nothing but the x coordinate, position of ID dot second, which is nothing but the y coordinate, x comma y. You can just simply return it in this way. And if you are asked for direction, make sure to take care of the edge case here. So if the robot is not moved, okay, then you can return east. Okay, otherwise all the directions as is told in the direction will hold true. So if direction of let's say id is equals to what? 0. Then return east, right? Uh, and just like that, you can have this for all the 4 directions: 0, 1, 2, and 3. If 0, 1, 2 is not there, the direction has to be 3, right? So east, after east, it will go north, it will go to west, and after west, it will go to south. So that is all. That is all for this problem. You see, you can simply try to run this and see if there are any errors. You see, we did get accepted for this one test case. We will run for all of them and check. Yeah, we did get an accepted, and we have a decent runtime complexity also. So yeah, that is all. That is all for this problem. I hope the solution was very, very clear to you, as well as the idea of making this vector. So yeah, that is all for this problem. If you still have any doubt, you can definitely ask me in the comment section. And that's all for this video. I will meet you in the next video. Till then, thanks a lot.